Okay.
Okay, again, welcome everybody. My name is Shelby Britt. We're going to be discussing today weight and balance. That's going to be one of your practical items in your PTS and for your O&P. The aspect of weight and balance, you could have any number of different types of questions that come up and are associated with it, everything from helicopters to weighing aircraft to all this other kind of stuff. But what we're going to be doing today is we're going to be talking specifically about how to do the basic weight and balance calculations. Now, technically I'm supposed to introduce myself and have all of you introduce yourselves to each other, and everybody go, oh, by the way, I'm so-and-so and I'm so-and-so, but you've been in classes together for almost 2 years. If you don't know each other by now, then a 5-minute introduction is not going to help. You got some social problems, okay? So let's deal with actually getting into the weight and balance aspects of the problem of what we're going on here. All of you should have gotten your G&A study guide, and if you looked in there on the pages that I mentioned to you earlier, I think it's like page 7 or 8, you'll have some weight and balance questions. You will see one of them that will have a 1 circle by it. That is the example of the first problem that we're going to be discussing this morning. Did everybody find that?
Yeah, but there's not one that's circled though.
There's not one that's circled.
Yeah, it just says 3, 4, and 5 are circled.
Go to the next page.
As you were.
As I was or as you were?
As you were.
Okay. All right. Let's start with the simplistic aspect of reading the question, because that's where most people make their initial mistake when it comes to calculating weight and balances. Weight and balance problems, they don't read their questions correctly. What we have here is it states an aircraft with an empty weight of 1,500 pounds and an empty weight CG of 28.4 was altered as follows. And it proceeds to explain if you had 2 seats removed, where they were located, how much they weighed, all of that. The first thing you want to do is you want to take this information and break it down into its simplest forms. Right off the bat, the first thing it tells us is that we had an aircraft that weighed 1,500 pounds. Its empty weight CG was 28.4. Then we made the following changes. Look at each one of these changes up here independently. My suggestion to you is that as you go through and you identify and rewrite this question, as you pull your information out of the question itself, mark it off. We had 2 seats right here. Each of them weighed 12 pounds each. Got rid of that. They were located at 65.5, which is right here, and they were removed. That means that we took that weight out. All right, now if you notice though, when we said we had 2 seats, there's 2 ways we can do this. Now, do you remember your weight and balance charts? How your forms that you drew up to be able to put the information in? They look like this. You'll see it again in a minute on the next slide. But you have your item over here. You have the weight. It's a column all by itself. Then you have the, what's next?
Arm.
The arm. And then that gives you what? Your moment. The last one is the moment. So what we have in here, in this particular case, we want to transfer this into a chart, is we had 2 seats. They weigh 12 pounds apiece. Now you can do this 2 ways. One is, you can say 2 times 12 is 24, or you can list it as 1 seat minus 12, another seat minus 12. The point though is since we removed that weight, then that's going to make that weight a minus. We had 24 over here, So we're going to have minus 24 pounds. Okay? The arm. The arm in this particular case was 65.5. The moment. Now remember, anybody remember here, real quick, how you determine whether an arm is a positive or a negative number?
By the location of the data?
By the location of the data. Now, that's a very simplistic answer, but basically what it amounts to is if the arm is to the right of the datum, it's a positive. If it's to the left of the datum, it's a negative. This particular case, we don't really, it doesn't say that it's to the right of it, but it says it's plus 65, so it gives us a positive measurement there. So what we would do is we would take the minus 24 pounds, multiply it times the 65.5, and that's going to give us our moment. Okay? Now, if you noticed here, as we went right down through here, we're going to go, this is all going to be much simpler because I'm going to have it on the next slide. We're going to actually walk through filling out one of these charts. Okay? Once we get all the way through this chart again, you're going to go, I remember this stuff now. And then I'm going to give you some problems that you can actually figure out. After we got through the seats, the next thing we had was a structural modification, increasing the weight by 28 pounds. And it was made at 73. So we have a positive arm there, 73. And we added weight to it, maybe as we built a cabinet in there somewhere or something. But we added 28 pounds to it. Then we had a seat weighing 30 pounds that we installed. And again, a positive arm. So that gives you two positive numbers. The last radio equipment weighing 25 pounds was installed at plus 85. Okay? Let's look now how all of this information fits into a chart. This is the breakdown of all, getting rid of all of the other words in it, the things that are there to confuse you. This is the basic information you need to be able to fill out the charts and go with. Here's your chart that we talked about before, how to set it all up. Draw up your chart, make sure you got plenty of room to add all your different items. The first thing we had was we had the empty aircraft weight. This is going to be our baseline calculation. This is where everything figures from. So we go through, we figure the weight times the arm, that gives us this moment. This is what we use to check and ensure that all of our information is actually designed and fulfilled from a basic understanding of what our baseline measurements actually are. We had the two seats. Remember? They were 12 pounds apiece. We took them out, so that's going to be a minus 24. Multiply it times the arm. Now here's the important point over here. If you notice, our moment is a negative number. So we're going to have to subtract that from this. Structural modification. That's what we did up here. Just plug those in. Here's the seat that we installed. And next comes the radio equipment. We've got this chart all filled out. Now we can look at actually answering the question. Anybody remember what the question originally was?
What's the empty weight? What's the CG?
What was it? New empty weight CG. Okay? The new totals right off the bat, first thing we have to do is we have to add up all these moments over here. And when you add in, make sure that you have your signs correct. That should come out to 47,312.
Yep.
Our weight over here, subtract it out where you need to. It gives us a new empty weight for the aircraft, 1559. If you divide your moment by the weight, that's going to give you your arm. And what is your arm? That's your new CG. So your CG on this one is 30.35 inches. That's your new center of gravity. Did everybody follow along with that? Yes, no, maybe, could be, possible?
How'd you get the arm again? You multiply?
What, right here?
Yes, sir.
Okay, we took our total moment. We took and had 42.6. We subtracted this, added this, added this, added this, and came up with this. Then we divided this, by what your weight is. And that gives you your new CG. Okay? Tony? Good?
Good.
Okay. John, you with us? All right. Next problem. This one is one that tends to confuse a few people sometimes. It's a little different. Now remember this, you're always going to have your formulas that are going to be provided to you during your OMP. You don't have to memorize any formulas. They'll always be available. Okay? In an airplane with an empty weight of 1,876 pounds, it's been altered. So this empty weight CG is 32.2. The CG range for weights up to 2,250 pounds is 33 to 46. So we have a range there of what our CG can actually be. The permanent ballast has to be installed to move the empty weight CG from 32.2 to 33. You have a bulkhead available at the fuselage station of 228 that's strong enough to support it. So what they're telling you is that you're going to have to change this empty weight CG. At 228 inches, you've got a place that you can put this weight. What they want to know is how much weight should you put there to be able to bring this back to within range. All right? Here's your formulas that you'll use. Now, this all looks a little Greek perhaps, so let's actually walk through it and see what these numbers mean. What you had up here, you had the first thing was the aircraft weight. So this is the first thing that you should do when you're doing one of these calculations. Draw out the formula. Put the formula on your paper, and then every time that you substitute in an item for one of the things in the formula, replace it and move on down. If you'll notice, I'm going to walk you through like 8 different slides here. It'll all be about this one thing, but I will always have this base formula right here at the bottom so I can look back at it and see what it is I'm actually adding back in so I can understand and follow along with how I'm doing it. The first thing it said I needed to have was the aircraft weight. There's the aircraft weight, 1,876 pounds. Boom, it goes right here. Times the distance needed to shift the CG. How far do we have to shift the CG?
0.8?
Huh?
Is it 0.8?
0.8 inches. Because you don't have to take it all the way over here to 46. You only have to bring it up to the minimum that it has to go to. In this particular case, 33 inches. So you take 33, subtract from the 33, the 32.2 that you had, that gives you 0.8 inches. Everybody see how I got that?
Mm-hmm.
With me?
Yeah.
All right.
I'm kind of lost how you plug in the formula, the numbers.
Okay. Let's go back one then. Read the formula. What are you looking for? You're looking for the amount of ballast weight you're going to have to put in, right? Isn't that what it says? You need to find out how much new ballast you have to put in based on this information? No?
Yeah.
Okay. What's your aircraft weight?
1870.
1876. So if you wrote this down, this formula down, another way to do it is to take and just mark this out. and round about 1876. Then we'll walk through and we'll resolve this. The distance you needed to shift it. Okay? You're at 33, you got to be between 33 and 46, right?
Yes.
Okay. Where are you at right now? 32.2. So 33 minus 32.2, and that's going to give you 0.8.
So you use 0.8 as the...
So you just use 0.8. So you've got 1876 times 0.8. That's going to take care of everything on the top side of the line.
Yes, sir.
You with me now? Make a little sense?
Yes, sir.
We good to go? All right. All right, let's see. Now, we need to find out what the distance between the balance locations and the desired CG is. Well, we know that, get an eraser here. We know that where we want to put the ballast is at 228 inches. That's the only point strong enough to hold it. So we put that down here, and we're going to subtract it from that what the desired CG is. How much? What do we want the CG to be?
33.
33. So you have 228 minus 33, and that gives us 195 inches. Did I lose you back there?
Oh, no.
Okay. Everybody with me?
Yes, sir.
Okay. Sometimes I'm not looking the right way. I don't hear heads rattle, so some type of input is appreciated. Fine. Now all we have to do is actually do the multiplication. Finish the math. Our top number becomes 1,500.8. Everybody get that?
Yes.
Yes.
The bottom number becomes 195. Divide those two, and you end up with 7.69 pounds. In most cases, in a situation like this, you're only going to go you're going to go to the 10 spot, so the 7.69 will actually end up being 7.7 pounds. Okay? Any questions about that? Nope.
Nope.
Here's another question. You got this question in your book. Okay, what I'm going to do is, you're going to be able to go back and look at all these. I'm going to very quickly go through and transfer this information into charts and show you how to solve like 2 or 3 different problems. We'll get through that, then we're going to be pretty much out of time for our videotape. We'll shut that down, and then we'll go in and discuss some tricks and techniques you can use that will make these calculations much simpler for you and ensure that you don't end up screwing it up somewhere when you're figuring out your totals. First thing we do, we have the same chart again. We've taken our empty weight, we've got it up here, plugged it in. We know what our momentum is, our moment is, because it's already listed up here. Everybody on the same, got this?
Yeah.
Set up? Okay. So we've got our moment over here. Let's see what's wrong with it. Okay. Here's something that you need to be aware of, though. In this particular case, we have alcohol that was removed. Alcohol, if alcohol is on board the aircraft, the weight has to be taken out. It's not included in the empty weight CG. Everybody remember that? What year did the weight things, did the weight rules change?
773?
Good guess.
Pretty damn good guess, actually.
No, I think it's actually 75.
Oh, okay.
But that's close enough. You were in the same decade. Okay. So we go in, we take the 20 pounds out for the weight of the alcohol. We know where it's at from the CG standpoint. That gives us our new moment. Now remember, since we had a negative number here, multiplied by a positive number, then we're going to subtract that moment from our total. Everybody follow that? Okay. The reason I ain't going further, that's just all as far as we needed to go. Because what did it say? What's the new empty weight CG and the new empty weight in the empty weight CG in the aircraft? The new empty weight is simply the 5862 minus the 20 pounds you subtracted of alcohol. That gives you the 5842. And your new CG, if you take your moment, subtract out this arm, that gives you your total moment down here. You can divide that by your weight, and that gives you your new CG, 151.37. Yeah.
Is oil not included?
No.
Or is original?
Oil is included. Oil is included in the empty weight CG of the aircraft. Okay. Now, if they had turned here, let's look at something that would not be included in empty weight CG. Let's say that you've got 20 gallons of water in a holding tank in the rear lavatory. That would have to be deducted from the weight. Okay? That's a consumable item. In this particular case, what they're saying is there's 43 pounds of oil in the tank. That's, for all practical purposes, that's the oil in the engine. Okay? All right, now, we've got another one, like we just did. Everything's going to be figured out exactly the same way. The only difference is we've got new numbers to plug in here. We're going to skip that for a minute. We're going to come back to it. This gives you another example. This is a problem that you have on your papers. Here's how the chart fills out for it. And it's basically the very same thing as what we had in the very initial problem that we did. The only difference is the numbers are changed. Now I can sit here and I can go through all the different problems involved. The one thing I want to cover with you is I want to cover a couple of little quick items that will keep you from making mistakes that will cause you to fail your OFE. As you go through and you do these weight and balance calculations, you come up with your totals. After you have completed your total and you got your answers, turn your paper over upside down and redo the problem again from scratch. Now you compare the answer that you got that time to the answer you got on the other side of the paper. If those answers are incompatible or different, somewhere you screwed up. You gotta go back and figure it back out again. Here's what most people tend to do, however. They'll figure out all these answers and everything on a chart. Then they'll sit down with their calculator and they'll go back and they'll take that information and they'll refigure it and they'll come up with exactly the same answer. You know why? Because they put the same information back in it again and they made the same mistake the second time. By turning the paper over and starting again from scratch, then what you're doing is you're eliminating the possibility of making a duplicatable mistake. A mistake that you made on the first time, you have a better opportunity, a better chance of missing it the second time around. Okay? Any questions about the basic parts of this, and then, like I said, once we get this tape cut off and we're ready to go on, we'll come back here and we'll go through this with some more detail. Yeah,
And what was the answer we just got on that one? Was it the 1.14?
I'm sorry?
Okay, sorry. You're gonna go over the one we just did, right?
Yeah, we'll be going over that in more detail in just a moment.
Okay.
But any questions about the actual concept itself, how the thing works? No? It all comes down to, the biggest single problem you're going to have when you're doing your weight and balances is normally your fingers. Especially when you got big fat fingers like mine.
And it's a really tiny calculator.
Huh?
And it's a really tiny calculator.
Yes. And that's why, and don't use your phone. That's why I said before, you said, well, I got a calculator on my phone. Wonderful.
If you can't take a test with it,
No.
oh,
Absolutely. Anything else? Okay, thank you. We'll cut this thing off and we'll get into some more details.